Hello, everyone, and welcome to Cloud Currents, a podcast that navigates the ever-evolving landscape of cloud and its impact on modern businesses. I'm your host, Matt Pacheco, Senior Content Manager at Terraform. And today's episode, we're going to talk to Ryan Raub, Vice President of Cloud Infrastructure at SmartRent, a leading provider of smart home and building technology solutions. Ryan brings over 15 years of experience in tech industry, starting his career in software development and moving into the private sector. As an early employee at SmartRent, he's helped scale the organization's cloud infrastructure to support millions of IoT devices while looking at issues like complexity, optimizing cost, implementing robust security measures, and much more. In this conversation, we'll talk a little bit about things like infrastructure as a code, dive into challenges of managing large-scale IoT on platforms like AWS, discuss a little bit about DevOps, and look at some emerging trends in cloud infrastructure management. So thank you, Rob, for joining us today. Or thank you, Ryan. Sorry, let me read that. Thank you, Ryan, for joining us today.
Oh, thank you for having me, Matt. It's a pleasure to be here.
Cool. So let's jump right into it. Can you tell us a little bit about your career journey and what led you to where you are today?
Sure. So I, first started off in a degree in computer science. So kind of the traditional software engineering background. From there, moved into working for the federal government. So, kind of almost as big scale as you can get. We had a HPC cluster, went through all of the fun aspects of large data, acquiring hardware, going through month-long procurement processes to get physical hardware, to at least purchase it, get it installed, and actually operational was painful for let's say. From there, moved to sort of a smaller scale. It was state government backed, and there we actually had a little bit of a journey from physical servers to hosted on-prem sort of private cloud, and then towards the end of my time there, completed a transition to AWS public cloud for them, and that was a fun journey. And then continuing with my progression to go even smaller, I joined a small scrappy startup at the time, SmartRent, under 100 people when I had joined. Definitely were, figuring out all of the pieces and parts for how do we do this and how do we scale this business and scale the infrastructure alongside it. We've kind of grown that up into a larger company now, and it's been a fun journey. And as going through that, we've figured out a lot of things. Figured out some really clever patterns and some fun ways to manage infrastructure at scale and also scale teams.
How's your experience in government work shaped your approach to your work at SmartRent?
So coming from a place where there's high regulation, there's defined processes for everything, and having to consistently navigate that labyrinth of bureaucracy, coming from that to, effectively a small scrappy startup, it's been, I'd say it's been a fun journey, because a lot of that, really, I think, speaks to the needs where we had to go fast. We had to figure things out. We, didn't have the luxury of having established procedures or, a cloud advisory review board to review changes before we, go forward with it. And we were having to kind of build up those processes and procedures as we scale to adapt to our size and complexity and our needs. And that's been, a great wealth of knowledge to sort of pull from. There's a lot of, I think, good standards and processes that exist in industry and in government that, are really, I think, established best practices. And so pulling from a lot of those, I would say cherry picking the ones for the right time, the right scale, you can't go full bore government level bureaucracy out of the gate at a startup. You'd never get your product out of the gate. So
it has to be a relief and sort of in a way. That's interesting. So you joined SmartRent as approximately what, employee like number 60, you said?
yeah, I'm in the
when we
60s.
first started in
Yeah.
the 60s. What's it been like to build and scale cloud infrastructure through that growth?
I would say, first of all, dynamic. We didn't start on the same sort of platform and the same sort of constraints that we are on right now. We're small shop. We had small needs, and we effectively used sort of providers that catered to those smaller needs early on. And as our systems have grown, our teams have grown, being able to, build those out, have those multiple teams, those multiple services, have those work in concert at scale has been an interesting evolution. We've had to bring in new tools when it was, when it all fit in one person's head, it was easy, and you could, add a couple people to that. But once you break out of, okay, well, you've got 2, 3, 4 teams that now all do similar things and similar patterns in parallel, how do we make sure that they're not all off, one team's off building in one direction, the other team's moving in a completely opposite direction? From a sort of operations standpoint, which is where I end up kind of putting my head most of the day, those additional complexities, those variations, end up making the operation side really difficult, and it's harder to either move people between teams or take somebody who's needing to span teams and have them translate from one to the other. So trying to keep those variations in step, and there are, of course, exceptions and to the rule, and keeping those variations in step, so that way, you're getting the benefit of, some of that consistency. You're getting the benefit of those security practices that you've got implemented in those modules, and you're able to actually go faster, and you're not having to solve the same problems and rebuild the same wheels in multiple different ways, but you end up with the same product at the end of the day. But not go too far to go back to the overarching sort of bureaucracy of, well, there's one team and they're the ones that do all of this, and so if you need a cluster or whatever, you go get in the queue there, and they'll get to you next month.
So we talked a little bit about SmartRent. Can you give us like a high level overview of what SmartRent does as a company?
Yeah. So our bread and butter really is, I describe it as sort of the smart home solution, but for multifamily. And so we really look at the resident experience, like what is it like to live in an apartment that has our hardware in it. And also the property managers. There's a lot of benefit that they're able to gain getting access control to common areas or to specific units themselves. We're able to provide control and functionality for residents to be able to use a smart lock that can unlock their doors with their phones, or enjoy. They can also control the thermostat with their phone or on their website or whatever, however they'd like to do that. I think those are things that once you kind of become accustomed to it, they really become a creature comfort that a lot of people desire. And so we really try to make that experience really desirable for them, but also deliver value to the property management company. And some of those things really, can include sort of SaaS solutions for how they manage their business. They also love leak detectors. That's one of the things that they will get a lot of value out of. And, from just an asset liability perspective, if you are able to, know that you have a system that will alert you if there is, a pipe burst or a leaky faucet or whatever, and you can get ahead of that and get that repaired before it becomes an extensive problem or, flooding. that saves you a ton of money and a ton of risk. So
Yeah, really interesting. What are so as part of the cloud infrastructure team, what are some of the big things you're focusing on to help with your company's product?
yeah, so some of the big things that we do that I think deliver a lot of value are around really just management of infrastructure and doing that in such a way. We're big believers of infrastructure as code. We're a large Terraform shop, so getting as much as we can into Terraform, getting away from as much of the ClickOps or the bespoke, hand created, cloud resources and configurations as we can, and also making sure that for me that adds a lot of visibility to the stack. If you're a developer on a team working with a service and you're unaware of how the actual intricacies of how the service actually works, and that's often a different either a different repo or managed by some Kubernetes YAML file somewhere else that you don't quite understand, bringing as much of that as close to the application as possible, because it truly is part of the application itself, and trying to make sure that we've got, good software development lifecycle practices and procedures in place. I mean, we it's called infrastructure as code for a reason. It's code. And that's one of the things that, we're really trying hard to make sure that we're managing and using, software and engineering principles, effectively, trying to manage the complexities of different solutions and trying to make sure that we are not over engineering a solution, or we are not, if we are, adding complexity to a solution, that complexity is warranted. The more complex solution, the harder it is to manage, the harder it is to observe, the harder it is to maintain, update, all those things. And so keeping a keen eye on and understanding the complexities of a system, and the better that we can kind of reduce that and keep that all within a repository, within code, the more effective that team is going to be at understanding how this service works and how we're able to troubleshoot and optimize it at scale.
So speaking of Terraform, what are some of the advantages that it provides over the alternatives?
There are many alternatives, and I enjoy the space where there's competition and there's cool ideas out there. I've seen a lot of interesting and novel approaches to this problem. For us, Terraform, it isn't vendor specific. Yes, I am saying Terraform. HCL. Maybe I can step back a little bit and the more general language. But we're not locked into AWS. We are not locked into GCP or any of the other providers that have either specific solutions for them. Having Terraform, having these infrastructure as code practices, we're able to leverage they're called providers, but we're able to leverage other platforms. The same approaches that we deploy there. We're able to manage our Datadog configurations. We're able to manage enrollment into group management, or in some cases like PagerDuty. We're able to control all of those configurations via code, which has, I think, really been a huge advantage. Onboarding is, basically a PR or two for some people, and then we're able to basically get them access. They get, invites, they're able to click and get in, and same with offboarding. It's all in code. It's all easy to review. It's easy to see, and provides a lot of consistency and guarantees. If somebody is in there changing something, we have history of what was there before, and also history of why did we have it configured before. I've got an entire Git history. I can go back and look at the various states of this particular monitor's criteria. Why did we move from this threshold to that threshold? And there's an entire sort of PR ticket discussion around the pros and cons and trade-offs, and that sort of that history is there, and it's nice to have that. Not a lot of tools actually provide that, and so being able to leverage those common patterns and practices across different providers, I think, has been a game changer for us, and what makes Terraform sort of stand out.
What strategies have you found, I guess, the most effective for managing Terraform at scale across like multiple teams?
That's an interesting question. I think there's a lot of different ways that you can go, and I'm going to kind of give an answer that's probably scoped more to my scale, my experiences. We're 500 person company roughly, so there are a lot of other challenges out there. I tend to lean on not a monorepo. That's so we have sort of an internal module registry that we maintain, and I've kind of made we've it's always nice to try things. That's one of the virtues of having a sort of startup or a team where we've got room to experiment and try things, and we've tried a couple different options, and coming back to simple is easy, simple is clear, simple is straightforward. Someone can pick it up and run with it. Doesn't take a whole lot of explanation. Breaking those modules down into separate repositories, treating them as their own thing. That tends to be a great way to manage those. We've even been experimenting a little bit, and there's some interesting, and there's room for debate using the sort of standard tools like Dependabot, for instance, to help manage updates, just like any other sort of software dependency, where it can come in and make a recommendation like, hey, I see there's a patch version for this. Would you like to, here's a PR, I can bring in the change log, I can show you, what the potential impacts are, and I can run your tests for you and make sure that, this isn't going to cause a regression. And so by doing this and treating these as sort of individual units, within our ecosystem, we're able to use those industry standard tools to help maintain those updates. There's a lot of other options in there for how to help manage these things at scale, and automation is a must. I mean, you can't be running Terraform apply from your desktop for everything. Like, that's just not a scalable solution. It's not secure. So making sure that the automation is set up, make sure the automation is consistent. Getting back to the complexities. If you've got one app or one service or one area that's inconsistent, and it's especially bad if it's an area that you don't touch every day, or you have people who are unfamiliar with it come in, and they're going to have either that learning curve, or they're going to make that mistake when they first pick this up, and they have an assumption based on the last 5 things that they've done and how they work, and this being different. So I think those are some of the big takeaways, I'd say, for how we manage infrastructure as code at scale.
Oh, that's great. That's great. Thank you for that answer. Let's talk a little bit about IoT and AWS a little bit. So from what I understand, SmartRent leverages AWS IoT Core for device connectivity. So excellent. So what unique challenges have you encountered implementing IoT at scale?
Well, we were one of the first earlier adopters to AWS IoT Core, which comes with its maybe not unique aspects. Anytime you're adopting a new service out of the box, there's a lot of early days, and both sides of the fence, the producer of that service or the host of that service and the client, both trying to figure out what works well, what doesn't, where can we make improvements, how does this actually work when the rubber meets the road. as we've been going, the APIs have been improving, the integrations have been getting a lot better. We can do so much more with it now than we can before. So it's really been a steady increase in what I would consider just effective use of the service as it's become a little more robust. It's one of those where nothing's perfect, but I think there are a number of managed services, across vendors that are very reliable and work really well. And it's pretty rare to run into problems or unexpected behaviors or unpredictable costs. This is one that is I think really matured nicely. It solves one sort of big problem for us, which is one that we've dealt with in other ways and other capacities. And I, don't see as much, discussion of this, but, when it just comes to managing long-lived connections. And so AWS IoT Core uses an MQTT protocol. So it's just a message broker protocol, but it's intended for high latency, sort of intermittent connectivity. It's not a super fast, meant to be low latency, so lossy. When you're maintaining a large scale of persistent connections to anything, rolling out change now becomes a much bigger orchestration and is a lot harder. The traditional sort of web server that if you were to, hey, I've got a new version of this I want to test out and I want to deploy, well, it's as easy as, adding those new instances into the load balancer. The load balancer slowly transitions over to the new instances. And as those requests, which, generally if this is HTTP, don't last more than 30, 60 seconds, 90 seconds at sort of maximum. But you have that sort of window to know that okay, any request in flight is completed. If this is a long-lived connection that is, hours, days, I don't have that sort of luxury. And so I've got to go through a orchestration process where I'm introducing new code, new application. I need to go through and gracefully move those connections over to that. I can't yank out from under it everything that was connected before. And you'll see some of this in WebSockets. I think that's one of those things where a lot of companies will, kind of ignore the problem, so to speak. And as they roll out code, they'll use the traditional models. And if you have those servers also serving WebSocket traffic, you're going to run into this exact problem. It just may not be that noticeable for you. So those are fun solved problems that we get from these managed services like AWS IoT Core, which has been really nice to have them deal with those complexities.
Speaking of complexity, there's also potentially security considerations. Can you talk a little bit about unique security considerations for IoT and the smart building technology you guys have?
Yeah. A lot of the things that we have are not unique. The vast majority of the stuff I would say is pretty standard in terms of approach, tools, mitigations. Some of the unique aspects for us really come into the cardinality of the data that we end up receiving. So, we've got, let's say it's 1 million or so devices out there that are all giving me telemetry. So if you wanted to, CPU utilization, that's an easy one. So if I had 1 million devices all trying to report to me 5-minute averages for CPU, and I'm, this is kind of a contrived example, but I'm trying to create a alert, or I'm trying to monitor, or I'm trying to figure out which ones are running at an elevated level compared to others. That's just a much bigger problem. And you can't really use your traditional tools that you normally would to, either alert or analyze that data to be able to bring those insights out. And so we've had to shift a lot of that kind of thing much more towards a data warehousing model where we can actually process data at larger scale in a much more scalable fashion. And so there's some unique aspects where we would love to have, we'd love to have more data, more specifics that we're able to get for every device. But it really turns into a data processing problem that we're having to work through on the back end. And then we also end up paying all of that cost to get all of that data. And so we need to be really careful with what are those specific signals that we want to make sure that we're sending, that we're receiving. And as it pertains to security, which is your original question, behavior analysis can be one. There's a lot of simple things that just having some regular data, having established patterns, and then being able to intelligently identify those and either raise awareness, fire off an alert, or in a lot of cases we can sort of include that into reports and make sure that is surfaced in sort of aggregate fashion as well. We've got a lot of protections in place for these devices and how they present themselves, their authentication methods. We've got a great hardware team that comes up with a lot of really good solutions there. We lean on a lot of industry standards for how we do these exchanges and make sure that these communications are properly secured, and that the data that we're receiving is coming from that trusted source, and we're not having to worry about these devices, I don't say falling into the wrong hands, but at the same time, if they start doing other things, they would stand out in our telemetry.
What are your thoughts on using automation and AI for cybersecurity?
It definitely can help a lot. I think synthesizing large amounts of data, finding correlations, can be of value. For me, it's been a mixed bag. There's been situations where I've seen huge value, it being able to pull together a correlation that I wouldn't have thought to go look naturally, or, just did not seem to, was just not obvious to a person. But since, it's able to churn through a lot more data than a person is, it's able to kind of highlight those. But I've then also seen countless times where it picks up on what it thinks are correlations, but in fact, they're unrelated signals or, whatever other it misses, I would say. So, I don't think it's a silver bullet. I don't think it replaces a person reviewing, especially security findings, but I for sure see value in some of the synthesis and some of the correlation. Anomaly detection is an interesting one. We use it in a number of different ways, and there are certain situations I feel where it can work well, and then there are many situations where it does not, and produces in fact probably more noise than the sort of source signal that you're actually trying to observe coming out of it. So it's definitely a tool. It's a tool you can use. It's a tool that helps, but it doesn't really replace a person at the end of the day.
Yeah, that seems to be something that we hear often. That it's definitely an assistant rather than a replacement. So thanks for sharing your thoughts on that. So we've spoken previously, and you mentioned we're switching gears. You've mentioned observability as an area you're passionate about. Can you tell us a little bit more about how you're approaching observability at SmartRent?
So observability, well, first off, you use a phrase which is uttered a lot. It's not free, and I think there's sometimes a misconception where, well, let's just add some more log lines, or let's just add this metric, or let's just add this observability into our application, and then we'll later on, maybe we'll need it or not. Or, you think about sort of unstructured logs, like if you're just adding in additional things, but not necessarily getting the value out of it, you end up paying a price either in processing that telemetry, that log volume, that that metric, whatever that is. You end up paying the the network costs, the CPU costs. There's a lot of things that we're having to really be careful with and optimize for signal noise. If we are going to log this particular event with these this context, is that a volume that we're going to get value on? And so we've got some team. I'd love to be able to tell a team, like, let's run the app in debug mode. Like, why not? We can pay the network fee. We can pay the costs for indexing all those logs, and we would have a better answer if a problem came up. We'd be able to know exactly what happened because we'd have the full trace. We'd have the full sort of gory details, and then the costs that come with that become huge. You end up finding out that, oh, you now need to run 20, 30, 40% more resources to host the same load, because now they're doing such a large job either maintaining state between processes or transferring log volume. They're having to ship up telemetry to a centralized system at a much larger rate. And then you have the other part where you're consuming that, and to make sure that you're having to either scale to accommodate that or scale your accounts payable department to cover that bill that you're going to end up paying. And it's always a bit of I don't want to say a battle, but it's a careful balance between what we're logging, what we're monitoring, what we're putting into our observability toolkit, and making sure that we're getting that value out of it. One sort of interesting area, and it's had a lot of iteration, I think, in the last couple of years that I've seen around sampling. And I think there's a lot of different approaches for it. There are some areas where I think it's a great solution, where you may not have your needs for observability may be better served by sampling and guaranteeing, at least 1% uniqueness of whatever patterns that you establish, coming from your various nodes. That may be enough data to answer your question. And if you can do that sampling upstream enough, you're not paying that network cost, you're not paying that ingestion cost. You are still paying that resource cost on the node, because it's potentially still logging or it's collecting that telemetry, and depending on where that sampling is. And that's where I think there's been some interesting develops pushing that sampling back. I mean, early on, you can sample at the ingest layer. You could have everything that it gives, it's able to take, 5-10%, and you're still paying that whole network transfer. It's moved back to sort of I've seen it at the agent level. So on a particular node, there's where it's kind of making the determination, is this a sample that I send up or one that I discard? And then even back further into the instrumentation itself, to, at the time of instrumentation, to understand, am I a sampled request or not? And that comes with interesting trade-offs, because if you're sampling some requests and those are the slower ones, but you're not seeing that you're trying to figure out why I've got two sets of, performance characteristics for the same calls, you can end up with, exactly, well, that's the overhead you're paying. So you can introduce complexities there as well. But that's kind of an interesting way to go about sort of managing, observability data at scale. For the most important part is making sure it's of value and useful, and you're going to be able to take action on it. You can't just log everything forever. It gets too expensive and too noisy.
Speaking of costs and expensive, because we just talked about it in the context of observability, but looking at it from a higher level, so at your kind of cost strategy at SmartRent, how do you approach that? Because like you said, these costs could get out of control if they're not managed properly. What's your philosophy and approach to cost optimization and cost containment?
Yeah. So, first and foremost, it's making sure we know what we have. And that is, it's a little bit back down towards observability. But if you have you need to have a good tagging strategy for how you understand, what belongs to what severity level certain things are at. And, you can go about spotting, from an organization perspective, you can go ahead and spot areas of, you know, right sizing opportunities. You can, make sure that those cost centers are, properly accounted for to a certain degree. There's always a lot of the, it's a, network egress cost. Like it's hard to, like, you can't put a tag on that necessarily. But there's, proper attribution, good understanding of what's there, making sure you have everything accounted for. You're not, finding a large open or Redshift cluster that someone turned on for a thing and then forgot about. So, driving all the way back towards infrastructure as code, as part of rolling out new resources, as part of, making change, if we're going to increase capacity or we're going to change resource types, there's a conversation and a pull request on that. And that usually is a good evaluation of, like, this is why, these are the benefits, this is, here's the justification for it. And so, we've got that history. We're able to kind of overlay that and make sure that, through, I say, regular evaluations, that we're, staying efficient. We're making sure that we're sticking with the tried and true paths. And then, of course, we're a large AWS. We have a large AWS footprint, so there's a lot of strategies that you can employ there. I think this has been good. They've moved a lot from their, really sort of locked in, like, reserved instance purchases where you had to buy, that specific instance class in that region on Wednesdays or whatever, crazy criteria they come up with to, make sure that you don't step outside of that. And then they give you a benefit of a savings that they give on top of that. And they've been shifting a lot more from that over the years to some of these more flexible options like savings plans. And so, we, regularly go through and make sure that we're, utilizing those effectively. And when we were able to make, larger commitments on, and that's always been one of the issues with the, reserved instances, like, cool, I can make it, all of the commitments start, they're usually in terms of years. So, 1, 2, 3, am I confident that I'm going to be running this particular database at this particular instance class in a year, in 2 or 3? And, that confidence, can vary a lot. And, they're willing to give you deeper discounts for, higher or for longer term commitments. And sometimes that's worth it. And other times that's a trade-off that you may not want to make if you find yourself needed to upgrade. And they've been doing a better job expanding this, but, if they've kept everything really rigid, and you can't, they have a concept called instance class flexibility. So, that's where they can kind of call these as like units of. And so if I were to go up from the large to the extra large, well, that's like 2 of the same units. And so I would just need to buy 1 additional RI that would get me, coverage there. But not in all of their product models do they offer that. And so trying to make sure that we don't, over or under commit the flexibility to allow us to, grow and scale and pivot while not wasting a RI or, taking advantage of those things. So that's been its own fascinating journey as they make changes there.
Yeah, definitely a journey. And I'm sure more changes in the future as well. Speaking of the future, let's talk about some trends we see over the next few years. What are What are some emerging cloud or IoT trends that you're most excited about in the next few years?
Yeah, I know I've seen a lot of growth in sort of the open telemetry standards. I think, the past couple of years, we've seen that really materialize as like this is a vendor agnostic way to provide observability data. I'm excited to see that continue and that to become basically the standard going forward. I know there's still some holdouts. There's still some things that need to be worked out with that standard, but I think that's a good thing for the industry. And I guess to play off that a little bit, we've also, been working with large scale sort of observability problems. And, I really see, there's a couple players in the space now who take a sort of data warehousing approach to this problem rather than the more traditional, approach where, they're storing things in memory and it's very expensive to, the per volume cost is pretty prohibitive to have that at scale. So seeing those things move to more of a data warehouse model has been really interesting. It's still early days. I think we're still trying to figure out how to properly query, manage, maintain, those pipelines in a sort of data warehouse approach. I think there's a lot of room for growth there. Yeah.
So we talked about this a little earlier, but I want to ask it at a grander scale. What role do you see AI and machine learning playing in cloud infrastructure management in the future, if any?
Yeah. No, I think that's the if any is a good qualifier there. So, one of the things that I've seen, and so I guess back to Terraform for a moment. So infrastructure as code, Terraform, it's a declarative language. You are declaring this is what I want. The idea is, and the pitch is, you don't have to care about how to get there. However, I think anyone who's used it for a while will clearly see, you really do. You really do have to understand how to get there. I can't go change that Postgres version from 15 to 16 and just expect it to work with no downtime. And like that's a sort of a pie in the sky. So I've seen a lot of improvement in tooling, understanding that change. You're proposing this new declared state. How do I get there safely and effectively, reliably, and not either fail in a safe way or make a sort of smoother transition or highlight that like, hey, this is going to be a disruptive thing. And there's a lot of learning that we've had to do with, there can be some really surprising changes that, unless you've done this before and you may not have realized that, changing this description on this attribute requires downtime. If you just send it as it were, you have to go through a bit of a two-step operation in order to seamlessly transition. And so I definitely see an opportunity there for AI to help highlight those things, potentially help provide solutions to help either train or, give more information to in the pull request. Hey, this is going to be a downtime event. We're going to need to, either take this approach or accept that. And potentially here's a pattern that we've, put in place for that. So to, as a way to help educate the teams and those rough edges, I think there's a lot of interesting opportunity to come out there, and also to review and potentially test. You've asked for this new declared state. Is it going to do what you think it's going to do? Is it going to solve that problem that you're after? I think there's ways to evaluate that using AI to help find those answers, to help highlight those areas where a human can kind of come in and provide that be provided more context and more information to make decisions. I think that's definitely an area of opportunity that I've seen some people scratching at, and I think there's a lot of room there.
Yeah, it's really exciting to think about. And seems to be the common theme, as I mentioned earlier, it's the common theme of helping people make decisions. Last question for you, and this is more kind of advice related. So we talked a lot about cloud infrastructure management, infrastructure as a code, Terraform. What is one piece of advice you would give organizations looking to adopt any of this technology to get started?
Yeah, if you're looking to get started and you don't have anything, or you don't have these practices, it's an uphill battle. And I've gone through a number of exercises trying to go from either a completely different set of infrastructure as code, or just a completely ClickOps based architectures, and tried to bring that into a sort of Terraform controlled process and workflow. And I don't think there's one solution to fit everything. I think you need to account for the change that is going to happen while you're going through this. I think that's an aspect that not a lot of people think about. It's easy to go, I need to go import everything here, and like, okay, I started, and 2 weeks later, all right, I'm done. Oh wait, it's changed. So being able to work progressively, stay in step with that infrastructure, with that change. I'm a big proponent of, start small, make it work, then make it better. So if you can grab some resources, bring those resources into, this flow, set up that automation for those resources, and it may be a subset, that's the place to start, and then build that out, because that will let you iterate. And so if you're making changes and they include those resources, you're able to include those changes now in the infrastructure as code pipelines. The transition time's painful, because if you've got multiple approaches to manage that infrastructure, and that's more areas for someone to forget or make a mistake or screw that up. So you don't want to let that linger for longer than you need to. But yeah, it's a tough problem. That's for sure. But I'm a firm believer that the end state is worth it.
It's excellent advice. And that's all my questions for you today. I really appreciate having you on, Ryan. This is very informative, especially about the infrastructure as a code, Terraform. We don't get to talk about it much, so it's really interesting to hear about it. So thank you for being on Cloud Currents today.
Yeah, well, thank you for having me. Happy to share some of my ideas and approaches to these problems.
Absolutely. We appreciate you. And for our listeners, thank you for listening in. Find us on all your major podcast platforms, and we'll see you soon. Thank you.